exercise 15.11 we're solving right now. Question number 8 is target to solve first time. It written the tangent to the curve at y equals to 6x minus x square at the point 2 and 8 intersect x-axis, curve the x-axis at the point P. They're asking to find the coordinates of P. So first we need to do one thing. We have to find out the equation of tangent. This is the equation of tangent. So let you find out this equation. This is the line of tangent. Equation of tangent we need to find out first. Tangent. So let you do this. To do that we have to differentiate dy by dx, and we got from here 6 minus 2 is x. If we put the value x equals to 2, then it will be gradient is 6 minus 2 into 2, which is 2. So equation of tangent you can write here. Equation of tangent, we need it. Tangent, the formula we know, y minus y1 equals to gradient m into x minus x1. This is the value of m we got from here, and that is the coordinate x1 and y1 value. X1 first one and y1 second one value, and x and y is the equation of x and y. So y minus 8 you can write gradient we got here 2, and then the value x minus 2. This is equation of tangent. We can simplify more, which is twice x plus 8 minus 4, and it gives us 2x plus 4. So this is our equation of tangent, and this equation intersect at the point P. So at P we can write at point P actually intersect with the x-axis means y equals to 0. We would consider twice x plus 4 equals to 0. Then from here we can get our value of x value, which is minus 2. So now our coordinate of P is minus 2 comma 0. This is the answer of the first part. Hope you understood the way we did. Second part, they ask you find the area of the shaded region. Let's see the shaded region. One of the part is under this tangent, which is still to here. So we can use the triangle formula to get our area from under the line to that line, and area under the curve we must have to apply the integration part. So I'm going to use different color to get out our area part. Area under the line we can write it say half into base into height, because this is the x value is 2 and the left side value is minus 2. So we can say this is the base. Our base is actually 2 minus minus 2, which is 4. We can write half into 4, then its height is, and that is the value of height. From here to there is the value of the height of this triangle, which you can say 8 is the height of this triangle. So half into base into height. Under the line we can easily do that, half into base into height, to get the area. Then and another part, the curve part, this is 6x minus x square. We have to write the curve part 6x minus x square. Under the curve there is no alternate except integration. So from 2 to 6 we have to integrate and put our limit. So let me finish it. So if we cut here, under the triangle we got 16, and let you finish our integration, which is 6x square by 2, or we can write 3x square. Then another part is minus x cube divided by 3. So we have done our integration. Let you put our limit 6 and 2. In that stage we can use our calculator to accomplish this area. Let you use our calculator. We know we have wonderful calculator to show you, so let me use it. So let's first write the equation 3 alpha x square, better 3 alpha x square. Let me write first, let me write again 3 alpha x is here, then x square is there. 3 alpha x square minus fraction alpha x. Alpha x means pink color here we are going to use x cube. Then the denominator is 3 given, put it 3. Now press the calculate button, and they're asking for the value of x. So on the top limit, our limit is 6. Let me put 6 and then press equals to again here, the equals to, then we got 36. So let you write 36 for 16 plus first value we got 36, then minus what is our second value. Again you can use this expression, just press calculate again. They're newly asking you the input value of x. So let we consider now the value 2, second limit or the lower limit, and it gives us, if I put here 2, then it also gives us 2. Okay, or 28 by 3 is the value for x equals to 2. So let me write 28 by 3. Okay, is it okay or not? Let me clear, make, do it again, calculate 2, then equals to, we got 28 by 3. So our now final calculation we are doing right now, which is 36, sorry, which is 16 plus 36 minus 28 by 3. So 28 divided by 3. And the value we got from here, which is 128 by 3, or if you write in the mixed fraction, 42 this. So 128 by 3, or we can write in a mixed fraction the value we got from here, 42 over 2 by 3. 42 over 2 by 3. Best way to write your answer in exact value. Don't write your answer in point unless any specification is given here. Let we move now to the question number 9 in that stage. 9, this is curve equation is given and the y-axis cuts at the point P, and the tangent to this equation at Q12 5 cuts the coordinate of R. So first we need to find out this coordinate R and P as well. Then we can do one thing, till to this point Q under the line. If we get the area under the line minus under the curve, then we would get the area shaded from here. So first we have to do, find out the coordinate of R. Coordinate of R, actually the tangent equation. Let's find out the tangent equation first. We need to differentiate to get the gradient of this tangent, dy by dx. Then definitely it would be half into 2, then twice x plus 1 to the power half minus 1, which is minus half. So you can cut out this 2. 2 comes from the coefficient of x here. Another is normal integration. So we can write it, say 1 by root twice x plus 1. This is our differentiation. Now we are going to put the value 12 here, x value, to get our uh, gradient from this equation, which is 12 into 2, 2 into 20, 12, 12, then plus 1. It gives us 20 plus 1, which is 5. So 1 by root 25, which is 5. 1 by 5 is our gradient. Now let me write our equation of tangent. Equation of tangent. Tangent, which is y minus 5, and our gradient is 1 by 5. Then we have to write here x minus 12. This is our equation of tangent. Now it intersects at the point R. R means y-axis. We need to consider in all the y-axis, all point of the y-axis x equals to 0. So we need to consider x equals to 0. When x equals to 0, let me write, when x equals to 0, then our y value equals to 5 plus 1 by 5, because 0 minus 12, and it gives us 5 minus 12 by 5. So we can use calculator to do that. This is our value, 5 minus 12 by 5. Yep, sorry, let me write again, 5 minus 12 divided by 5, and it gives us 13 by 5. Let me write 13 over 5 is our gradients. Sorry, this is the value of the y value of the coordinate of R. So let me write the coordinate R, whereas the x value is 0 and the y value is 13 over 5. Let me keep it like this. This is not our question. Now we need to find out the coordinate of P. Coordinate of P, actually it intersect with the curve y-axis. So this is our y-axis equation. To do that, we again consider in y-axis x equals to 0, then y becomes, say, y equals to root, because we got x equals to 0 in one axis, 2 into 0 plus 1, and it gives us 1, positive 1. So our coordinate of P, we can write 0 comma 1. These are coordinate of P. Now under the straight line, you can say this is a trapezium. We also can do by doing the integration under the line from 0 till to the 12, but it's best way to do it by using the trapezium. So trapezium area, we can find out the whole area by doing one thing. This is the trapezium. See, trapezium looks like that. Trapezium area minus Curve area is actually, it looks like that under the curve area. Then we would get this shaded area from here. So trapezium area actually, we know half of a plus b into h, this is our trapezium formula, minus area under the curve. We have to integrate the curve equation, which is twice x plus 1 and its power is half, and we need to put the limit from x. This is the coordinate x equals to 0, and this is the coordinate x equals to 12. From 0 to 12 we have to put 0 to 12. So let we finish now. Half into a plus b, which is two parallel sides. So if we consider coordinate of r, it is given here 13 by 5. So if we consider one value is 13 by 5 and another value p is this height we are considering, second height is this height, the b value which is 5, and difference this between these two value is called the h, which is 12 minus 0. We can write here 12. This is the total area of the under trapezium. Now we are going to integrate this twice x plus 1. If we integrate, then it should be 2x plus 1 to the power half plus 1, which is 3 by 2. And one important thing, we need to divide that thing with 2 by 3. So we can write here 3 by 2 means 2 by 3. If we make it reciprocal, and coefficient of x, which is half, we have to multiply that. So this is our integration of this part. Let me put the limit from 0 to 12 to 0. Now it's time to finish our part. On the left side, it gives us a, let's use calculator to do that. 0.5 bracket 13 by 5, 13 over 5. Let me write the thing exactly what it is written. Plus 5, close the bracket. Then outer side is into 12. We can write here. Oh, sorry, I have given here two cross sign, 12. Then it gives us 228 divided by 5. Let me write here 228 divided by 5. This is our area under the straight line. Now we need to subtract the area under the curve, which is this. We can cut out that. So minus 1 by 3, and let me put our limit here. Equation is 2 into 12 plus 1 to the power 3 by 2, one part, then minus 1 by 3, 2 into 0 plus 1 to the power 3 by 2. That is the total part, which is 228 divided by 5 minus inside, actually this is 12, 24 plus 1, 25 square root of 5, 5 to the power cube is 125. So you can write 125 by 3. From here we got, then minus, this is 1 to the power 3 by 2 is 1, so minus 1 by 3. Now our final answer 228, we already have wrote here 228 by 5, then you can write here minus 125 by 3. Right, to write 125 divided by 3. Sorry, I did a mistake. 125 divided by 3. You're welcome to write if I did any mistake. So because I'm doing it live, better to comments on the chat box, better, plus, because it minus minus plus. So final answer is 64 by 15. 64 by 15. I would suggest you can write in the mixed fraction. Don't write it as a point, infinity point. So 4 over 4 by 15 unit square is the answer of this question. Hope you understand. Let me show you how we did. This is something actually you need to find out the area under the line, then area under the curve. Area under the line, actually it forms a trapezium. This is the format of the trapezium. So in that stage, actually height from the left side we got the coordinate of r, which is 13 by 5, and on the right side height, actually 5 is the height, y value is the 5. What do we use here? Yeah, so this is the second height, y value, and this difference makes the, actually that difference is the a, this difference is called the b, and this is the h. H is actually 0 to 12, which you can write here 12. So with this information we can find out the area under the line, and area under the curve. There is no other alternate except integration. we have must part from the integration. From 0 to 12, we integrated this one, curve equation. And after the integration, this is the integration, then put our limit, then we got this one. If you don't know the normal integration, you're welcome to my previous videos. There are a lot of integrations are there with the normal integration, trigonometric integration, exponential integrations, everything is there. So hope you would understand from there. Then let's move to the question number 10 now. In question 10, it's very easy to find out the area under this bounded area. This is the bounded area. In that stage, we have to consider one thing. We do not need to see what the x-axis is. We have to see the part where the equation of the top part equation, I mean the above one equation is this, and lower curve equation is that. So, and bounded by two places from it started from x equals to 0, and then other part is till to the pi. So just integrate under these two curves. The first one is, we can write the thing like this, 2 plus cos twice x from x0 to till to pi. Then we also can write the lower curve, which is this, directly right here, minus 1 plus 2 cos 2x. If we integrate together, keeping the upper one curve, then minus the lower one curve, and limit is like this, then we would get the answer directly. We do not need to think what the x-axis is, what the y-axis is. From the left side limit to go to the right side limit. This is the how we are going to find out the bounded area. So now just simplify it. We can simplify, say 2 minus 1, which is gives us 1, then cos twice x minus 2 cos twice x, it gives us minus cos twice. See, the equation is so simple now to integrate and put the limit. So just integrate it. 1 gives us x definitely, then minus cos, if we integrate that, it gives us sine. The coefficient of x is, we needed to write first half sine twice x, put your limit, one is pi, another one is 0. So we are going to put the limit, pi minus half of sine twice pi is here, then minus, we are going to put the 0, then x0, then minus half sine 0. We know sine 0 is also 0, and so we got the value is pi, because sine twice pi, as we know, sine twice pi, sine pi, everywhere this is 0. Sine twice pi, sine 0, sine pi, all values are 0. Here everything is 0. So pi is the answer, and you can write it in square answer. That's it. So hope you understood the questions we have done for you from here. This is the exercise actually 15.11 we are doing, and all the questions I have done from Cambridge Admit book. Thanks for watching.